universal Turing machine. Before going into universal Turing machine, let me start with the difference between a Turing machine and real computers. So usually we'll design Turing machine to accept a language a power n, b power n such that n greater than or equal to 1. We'll design a Turing machine to compute a function f of x is equal to x plus 1. So always we design a Turing machine to execute or compute one program. Whereas real computers are reprogrammable. And what other difference we have? In Turing machine, we have a tape. We'll use a tape which is infinite. The tape is infinite. In real computers, we'll be using a memory that is finite. Okay. Now, we come to the definition of, with this difference, we come to the definition of universal Turing machine. Now, universal Turing machine, it is a Turing machine. It is called as universal Turing machine if it simulates the behavior of digital computers. So, we call a Turing machine as universal Turing machine if it simulates the behavior of digital computers. So, in digital computers, if suppose this is a digital computer, we will be giving some input. The computer will be giving us the output based on some algorithm. Okay, we'll be giving us a step-by-step instructions to the computer to tell how to process this input according to this algorithm. Now, if we can say a Turing machine as universal Turing machine, okay, if this Turing machine accepts both input as well as algorithm and it performs some task. So, it performs some task, maybe gives some output. This is the case for a Turing machine to be an universal Turing machine. Now, how will you define a universal Turing machine? See, we will be defining an universal Turing machine as an ordered pair MW such that M is a Turing machine and W is a string accepted by M, or M accepts W. Okay, so a universal Turing machine is a collection of all M and W. What I mean by say M and W, so we'll be giving the input to the Turing machine, universal Turing machine, M. M is nothing but a description about some Turing machine. And W is an input string of M, for M. That is what is W. If we give this as the input, what action the universal Turing machine will perform? The universal Turing machine will simulate M. Okay, what I mean by simulating M, the universal Turing machine will check whether the machine, that is this M, accepts W, accepts the input W. Okay. So, this universal Turing machine is a collection of all Turing machines and the input to this machine, input string to this Turing machine actually. This is what is universal Turing machine. Now, why it is important is, see, universal Turing machines simulate the behavior of digital computers. That is why it is more important. The importance of Turing machine is that it simulates the behavior of digital computers.